Let's start by defining our input parameters into the C# scripting component. So the first thing we need is our targets, of course, and we are going to define this as a list, and also this should be a list of point3D objects. Then we need the origin for our tree, which has to be also a point3D object. And finally, what we need is a control parameter, let's say a boolean, so that we can control when we want to reset animation. And then let's define these input parameters with Grasshopper. So for the targets, what we're going to do is to populate a center box of points and use those points as targets. So this is my box. Now let's populate it. And let's say that our domain is, in this case, 5 meters by 5 meters by 5 meters, like this, sorry. And the base plane is the point, in this case, 0, 0, 10, for instance. Okay, alright, so these are my targets. We can leave the other parameters as they are by default. And now as the origin, let's define the point 0, 0, 0. Okay, and finally, we will use a Grasshopper button to control our animation. Okay, great. Okay, so now we are ready to jump into our C# component and start defining our classes. And the first one that we need is a class to define our targets or leaves. Like this. So this class is going to have two properties. The first one, of course, is the position of that particular target as a point3D object, and the other one is a boolean to determine whether that target is already reached or not. And of course, we also need a constructor which assigns the input arguments into those properties. And the next thing that we need, of course, is the class to define our branches. So this class is going to have the following properties. First, the position and the direction, which are the main properties that define a branch. And we also need to define another property for the parent branch, which of course needs to be another branch object. And we also need a counter parameter, which will determine how many targets are in range of that particular branch. And we also need this vector safe direction whenever we want to reset that counter and that particular branch, as we are going to see later. And finally, we are going to define the length of our branches as a private variable instead of as a property, because we are not going to call this value outside of this branch class. And the next thing that we need is, of course, our constructors. So first we will start by defining a constructor that takes as arguments the position and the direction of that particular branch and assigns those values into our properties. And we will also define another constructor that takes another branch as input argument, like that. And in order to define the position of this new branch based on the parent branch that we are passing as an argument, we are going to call this next method that we will see in just 1 second. So we are not seeing the meaning of all those properties and constructors yet, but stay with me for a second and you will see how it makes sense in just one moment. And of course, as we said, it's possible to define different constructors for the same class as long as they take different input arguments. So as we said, now we have to define our next method that we are already calling here. So this method will actually return the position of the next branch based on the parent branch, like that. So we are going to define the position based on the position of the original branch and a vector, which is of course the direction multiplied by its length. And as we also said, we need another method to reset our branch whenever we want to reset our counter of how many targets are in range of that particular branch. And as a direction, we are going to take the direction that we saved previously into this vector. And again, we are going to see how this exactly works in just 1 second. And the last method we have to define inside of this branch class is a method to draw the branches as lines into Rhino. So we are going to call this method toLine, and it's going to return a new line, which is taken as arguments for this constructor the position of the original branch and the actual position of this branch. So these are basically the endpoints of that branch. Okay, so that was everything regarding our branches, and now let's define finally our tree class. So first of all, this is our tree class that we are going to define for this tree growth algorithm, but it has nothing to do with the data tree objects of Grasshopper. So let's start by defining the properties of this class. The first thing that we need is this maximum and minimum distance variable, which will control whether the targets or leaves are in range or not of the branches that have already grown. And then we need this other control variable, maximum size, and this will be very helpful in case that the tree doesn't find any other target. So this variable will prevent the tree from going on growing until the end time. And finally, we need these two other properties in order to assign our targets and branches so that the growth algorithm can take place. And again, the next thing we need to do is to define our constructor. So let's do it like this, public tree. And now as input arguments, we're going to take the initial position of our tree as a point3d object, initial position, and then we need to define or to assign our targets, of course. And this is going to be a list of point3d objects and target positions like that. Okay, I hope I haven't made any typo. So now, So basically now pay attention because it starts getting a bit complicated. So first we have to define to assign the properties of our tree. So let's start with a list of branches. In this case, this is very simple because it's just an empty list. And now we have to start assigning our targets that we already defined as an input argument of this constructor. So we are going to define those targets in this way, just basically as a for each loop. So we are constructing our new target objects right here, and of course we are setting them as false because they are not reached yet. And then what we are also going to do inside of this constructor is to define the tree trunk. So we are going to do it like that. The first part of the tree trunk, which is called the root, is going to be a branch which is going to start in the initial position. In this case, we define that as the origin of coordinates, but let's see that later. And as initial direction, we'll use the z-axis vector, which of course is again a static property of the vectors3d class, which you can find in the Rhino common documentation. So this is our root, or the first branch of our trunk, let's say. And what we are going to do is to keep growing this tree trunk until we find the next, the first target that is in range. So what we're going to do is, while this, and remember this exclamation mark, it means not. We already saw that with the conditionals. So let's say, while this tree is not close enough, and we are going to see with this method means later, and also if these branches are within this size, as we already said, then we are going to add a new branch to this tree trunk. So the tree trunk is like the first part of the tree. There is no ramification here, and as I said, we are going to grow this trunk until it finds the first target in range. Okay, so the constructor works like that. And of course, we now need to define this close enough method. So basically, what we're going to do is to take a branch, and we are going to check if the targets of that we assign to this tree are in range or not. So for that, we are going to use this maximum distance variable, and this variable, this does have nothing to do to decide whether these targets are already reached or not. It just means whether they are in range so that the branches can start growing in that direction or not. So basically, the first thing we need is to calculate the distance between that target and that branch, and later on we check if that distance is smaller than this variable here. And again, we are using this keyword to specify that the targets are the targets property of this particular class. But if the compiler is clever enough, it shouldn't be necessary to write this keyword. The next method that we have to define is, of course, the draw method in order to draw all of our branches as slices into Rhino. So what we are going to do is basically to use this for each loop in order to call the toLine method that we already defined inside of our branch class, and that returns a new line for each branch that this tree has. And the last method that we have to define is, of course, the grow method, but we are going to take some more time for this one.